Hey everyone, I'm on to question 3 now of this quadratics test for IB1. And question 3 has 4 parts to it, each one asking to give the equation of a quadratic. So part A has a quadratic that passes through the point 4, 1 and touches the x-axis only at 2. So when we're developing equations for quadratics from either information or a picture, we want to think about our 3 different methods, right? So we've got factored form. Factored form basically comes in this form, and we can remember it's called factored form because we have these 2 brackets that look like they're factored already. That's really helpful when we have x-intercept information. We've got vertex form, which is really helpful when we have vertex information, so the max or the min of a quadratic. And then we've got standard form, and we're rarely going to plus bx plus c. We're rarely going to use standard form when we're actually developing the question. We'll usually be given standard form in a question and have to develop it into one of these. So basically I would focus on these 2 concepts and what are you given in the question to point you in the direction of which form to start building your equation in. So let's read our question one more time. We've got a point that we're passing through, so that's neither an x-intercept or a vertex necessarily. And then it touches the x-axis only at 2. So if we think about what that might look like, if we've got, here's 2 on the x-axis, if it only touches the x-axis there, so it doesn't go through the x-axis at all, our graph must look like either this, where it touches there, or this, where it touches there. In other words, the point 2, 0 must be our vertex. And sometimes they're tricky with the language. They'll say it touches the x-axis versus crosses the x-axis. So when it just touches the x-axis and bounces back off there, that means it must be the vertex. And we know that when we have the vertex, we want to use vertex form to develop our equation. Every time we're developing an equation, we're basically going to end up trying to solve for this a. So let's see where we're at. We've got y equals a, we don't know, x minus, this will be 2 because we know the x coordinate of the vertex is 2 squared, plus this is usually the y coordinate of our vertex, and since we know it's on the x-axis, that'll be 0. So we don't even need to write that part. So we've got y equals a, so some constant times x minus 2 squared. We know that a can be anything because all that does is vertically stretch the graph. So now we use our other piece of information, which is the fact that 4, 1 must lie on here. Sub those in for your x and y and solve for a. So at 4, 1, y is 1 equals a, we're still looking for. X we're calling 4 minus 2 squared. This gives us 1 equals a times 4. 4 minus 2 is 2, squared is 4. So a must equal 1 over 4. Then you sub that back in, so our final answer is y, in vertex form, they didn't specify which form, is y equals 1 over 4, because that was our a, x minus 2 squared. And we can see this is in vertex form where clearly our vertex is the point 2, 0. So it's as simple as that. Realize what you have in the question, whether you have information about x-intercepts or your vertex, that will point you to which form you're after, and then plug in the other piece of information you have to solve for a. Hopefully this is helpful. We'll see you for part B and C and D.